Hey math explorers, have you ever thought about what the middle value in a crowd means? Let's say you and your friends line up by height. The person standing right in the middle divides the group into two equal halves. That's our median. It's the one that says, half of you are taller than me and half are shorter. Pretty cool, right? In statistics, the median represents that middle observation, the value that perfectly divides your data into two equal parts. If we have data that's not grouped, we just arrange all numbers in increasing order and pick the middle one. If the number of observations is odd, the median is the observation at position open bracket and plus 1 close bracket divided by 2. If it's even, then it's the average of the observations at positions and divided by 2 and then divided by 2 plus 1. But for group data, things get trickier. We can't see each value, just classes like 0 to 10, 10 to 20, and so on. So, we estimate the median from these intervals. Think of it this way. If you're checking income data, the median income tells you the typical earning level, unaffected by billionaires or zero-income outliers. That's why the median is a favorite in economics, sociology, and even business analytics. So how do we find this magic middle when we only have classes and frequencies? For that, we'll need the concept of cumulative frequency. Alright, cumulative frequency sounds big, but it's actually simple. Imagine stacking blocks. Each block's height represents the frequency of a class. As you stack them, you get a running total. That's your cumulative frequency, or CF for short. We usually prepare two types. The less than type, where each entry shows how many values are less than a certain limit. The more than type, which shows how many values are greater than or equal to a certain limit. For example, in a marks distribution of 53 students, if 8 students scored less than 20 and 12 scored less than 30, then the cumulative frequency keeps adding up. 8, 12, 15, and so on. It's just like counting how many students scored up to a certain mark, a bit like checking how many friends finished the marathon before you. Now that we have the cumulative frequency, let's see how we use it to locate our median class, the one that holds the middle position. Okay, step 1 to find the median. Find your median class. How? Super simple. First, add up all frequencies to get total observations denoted by n. Then, divided by 2, that's your halfway point, and divided by 2. Next, look for the class whose cumulative frequency is greater than and closest to and divided by 2. That class is your median class. For example, if there are 53 students, then and divided by 2 equals 26.5. Now, check the cumulative frequencies. The one just greater than 26.5 is 29, corresponding to the class 60 to 70. So, 60 to 70 becomes the median class. In short, the median class is where your data's middle child lives, not the youngest, not the oldest, but the one smack in the center causing all the balance. Now, once we know the median class, we can calculate the exact median value using a formula. Let's explore that next. Here comes the star of the show, the median formula. It looks fancy, but trust me, it's easy once you know what each part means. The formula is median equals L plus open bracket and divided by 2 minus CF close bracket divided by F multiplied by H. Let's decode that. L is the lower boundary of the median class and is the total number of observations. CF, cumulative frequency, is the total frequency before the median class. F is the frequency of the median class and H is the class width. This formula basically adjusts the lower limit of the median class by a proportion that shows how far into that class the middle lies. Think of it like measuring how far up a ladder you need to climb to reach halfway. You start from the lower rung, L, move proportionally based on how high you've gone, and divided by 2 minus CF, and use H to stretch or shrink your step size. Let's apply this step by step with real examples to make it crystal clear. Example time. We have marks of 53 students distributed across intervals. We already identified the median class as 60 to 70. So, L equals 60, H equals 10, F equals 7, CF equals 22, and N equals 53. Now, N divided by 2 equals 26.5. Substitute in the formula. Median equals 60 plus open bracket 26.5 minus 22 close bracket divided by 7 multiplied by 10. That gives 60 plus open bracket 4.5 divided by 7 close bracket times 10 equals 60 plus 6.4 equals 66.4. So, the median marks are 66.4, meaning half the students scored below 66.4 and the other half scored above. This gives teachers a clear dividing line. 66.4 marks separate the top and bottom halves of the class. Now let's look at another situation. In this example, we are told that the total number of observations is 100. The median is 525, but some frequencies x and y are missing. We start with what we know. Total equals 100x plus y equals 24. Median class is 500 to 600. So A equals 500, H equals 100, F equals 20, and CF equals 36 plus x. Now, using the formula, 525 equals 500 plus open bracket 50 minus open bracket 36 plus x close bracket divided by 20 multiplied by 100. Simplify step by step. 525 minus 500 equals open bracket 14 minus x close bracket times 5. Giving 25 equals 70 minus 5x equals 45x equals 9. Substitute in the total equation. 9 plus y equals 24, y equals 15. So, the missing frequencies are x equals 9 and y equals 15. See? The median not only finds the middle but can also complete missing pieces of the puzzle. That's statistical detective work. Now let's wrap up by comparing the median with the other two central measures, mean and mode. Alright, let's summarize everything we've learned about the median. The median divides the dataset into two equal halves. It's the central value that's not easily influenced by extreme highs or lows. Its formula, once more, median equals L plus open bracket and divided by 2 minus CF close bracket divided by F multiplied by H. Now, let's see how it stands next to the other measures. Mean considers all values but gets disturbed by outliers. Mode finds the most frequent value. Median, our hero, stays strong and steady, perfect when you just need the central figure, like median income, median height, or median age. There's also a relationship tying all three together. 3 times median equals mode plus 2 times mean. So, the median really is the balancing point, a stable measure that works even when data behaves wildly. And that's how we find the median of group data, the perfect middle ground in a sea of numbers. In the next video, we'll explore how all three measures, mean, median, and mode, come together to tell one unified story about your data. Until then, keep finding your balance just like the median.